today is 3-2 rational numbers, and your first vocabulary word is rational numbers. Okay? Yeah, go figure, huh? Rational numbers are anything that can be written as a fraction. Anything that can be written as a fraction. So, what are some things that can be written as a fraction? Decimals, regular fractions, and what else can be written as a fraction? Whole numbers, right? Whole numbers. Integers, whole numbers. How would you write a whole number as a fraction? Evan, stop talking. What's that? Or what about if I have a whole number like 3? How am I going to write that as a fraction? 3/1. Remember, it always goes over 1, so don't forget that. So the 3 things you need to have written down are these. Okay, because these are the 3 things that can be written as fractions. And somebody said, well, can't a percent? Sure, a percent can be written as a fraction, but we could also make that a decimal, which in turn can be written as a fraction. So yes, percents can also be written as a fraction. But these are the 3 things that we're going to discuss today. Integers, fractions, decimals. And then I just give you some examples behind. All right, are you ready? Because this next page is going to be where we draw the picture. So in your notebook, find where you want to draw my big picture. And if I were you, I would turn my notebook like this. No, we're not done taking notes. Okay, so before we do anything, I'm going to explain a little bit to you. Okay? So what you're going to do is you're going to turn your notebook, okay? And the first thing I want you to do is I want you to draw a line down the one side. I want you to have it small but big enough to write in. Small but big enough to write in. So like right where your pencil is, Riley, draw a line all the way down. Yep. Good. Small enough, but big enough I can write in. So this is like perfect. Yep. And if it's a little smaller than that, that's fine. Okay? Now before you do anything else, okay, I want you to draw a little circle. Not all of these circles, just draw a little circle, but it has to be big enough that you can write in. Okay? I don't know, quite a bit. Yep. Now listen, what we're doing here is we're still talking about rational numbers. Do you know what an umbrella term means? Okay, so rational numbers is an umbrella term. And what that is, think of like an umbrella. Okay, think of what it covers. Okay, an umbrella term is a term that has different groups underneath of it. Does that make sense? Okay, so we're going to talk about those different groups in rational numbers. Okay, so the first group is going to be in here, and we're going to write the word natural. And this is one of our groups underneath rational numbers. What's that? No, we're going to do a few examples in there too. So natural numbers are anything from 1 on that are whole numbers though. So like 1, 2, 3, 4, 5, 6, 7, 8, all the way to a bajillion or whatever. Okay, so let's write some examples of natural numbers in here. Well, 1 would be an example. What else? 4, 100, sure. 2, 22. I'm just going to write a few examples of natural numbers so you know what that looks like. So natural numbers is from 1 on. So then my next, I'm going to draw another circle around that now, big enough that I can write in, but small enough that doesn't take up my whole page. And in that one, I'm going to write whole. We've talked about whole numbers before. That's a little big, but that's okay. You're going to have to get another circle around that yet, Riley. Okay? And whole numbers are the exact same as natural numbers, but there's one small difference. 0 is included in this one. So if I were you, I would make sure I have 0 written in there, and you can have 10, you can have 50, you can have 73. So what's the difference between whole and natural again? Yeah, whole has 0. Yep, very good. You're doing a good job. Then you're going to draw another circle. This is your last one. And in this circle, you're going to write integers. What are some integers? Any number that's negative or positive, and 0. So let's write some examples of integers in there. So like -3, 7, -100, 36. You could have 0 in there, sure? Sure. Okay, so we're not done yet. Our last one, we aren't going to draw a circle for, but we're going to write rational numbers. Or just rational, either one. Okay, now remember we talked about different types of rational numbers? And we talked about before what can be turned into a fraction. What were some things that we had that could be turned into a fraction that we talked about? Decimals, you can have repeating and terminating. Remember, because those are the two things we talked about yesterday. So in here, I would maybe put like 2.3 repeating. You could have 4.5. And then we also talked about fractions, right? So you could have like -1/4. You could have 3/8. But you can also have whole numbers too. Sure, so you could do like 6, 11. Kind of, yeah. We'll talk about that in a second. Sure, we can put a -4 in there. Yeah, go for it. Okay, and then the last thing, so we're done with that now. So you got some examples of each kind so you know what kinds of numbers are in each kind. The last thing I want you to do, I want you to start at natural numbers, and I want you to make an arrow out. And I will explain to you how this works. It's kind of like a train. That arrow is kind of like a train. You're going to get on it, and you're going to take a ride. Okay? So what's going to happen today in your homework is it's going to give you a number, and it's going to ask you what type of number this is. So Kenzie, pick a number. 10. Good pick. I'm going to start at natural numbers. Can 10 go into this? Yes. If 10 can go into this, you're going to ride the arrow and go out. If you can ride the arrow out, it's also a whole number, it's also an integer, it's also a rational number. Correct. Correct. Okay? How'd you put the arrow? Because it's like, okay, if I end up here, that means I go out, it's everything else. Nothing is ever negative in natural. If it's a negative, where does it start then? It's an integer and what else? Rational. Okay? So if I ask you, what would 0 be? You think to yourself, okay, am I a natural? Okay, no. Where am I? I'm going to start at whole, right? And I'm going to follow it out. So if I'm a whole, I'm an integer and a... Not difficult. Yes. And then sometimes I might say, well, what is like 2.3? It's just irrational because I can't pick up here, that's where I start. That's it. Okay, do you see how it's going to work today? So like I might say 4.5. What kind of number is 4.5? Rational, right? That's only whole numbers, whole numbers positive and negative. That's where I can start with my fractions. Okay? So far, so good? All right, so then you're probably wondering about this little guy here that we haven't filled anything in yet. This is where your irrational numbers goes. Okay, so irrational, I-R-R-A-T-I-O-N-A-L. I just wrote it like that because I don't have enough room. irrational numbers, or any numbers that can't be turned into a fraction. So these are numbers that cannot absolutely be turned into a fraction. These are like, what would you say that's something that can't be turned into a fraction? That can be. And I'm going to show you that today. 83 over 5? Irrational number would be like pi. 3.1415928, yada, 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 yada. Something that doesn't have any rhyme or reason to it. So an example of an irrational number, you can put pi. Or you could do like 4.12123694837 dot, dot, dot. Do you see? Yeah, that's fine. Cannot be turned into a fraction. Yep, if it would terminate. Yes. Yes. So like in rational, I'm going to go back here, you guys. Remember I have this? This would be terminating and repeating. Can be put into fractions. And I'm going to show you how to put repeating decimals into a fraction. Yesterday we talked about terminating decimals can be, remember? Because, remember we talked about how these can be turned into fractions? They're terminating. This would be 34 hundredths. And then you can reduce, remember? Okay, so repeating decimals, I'm going to skip some of these because you guys know how to do this already. I'm going to show you today how repeating decimals can be put into a fraction. Okay, are you ready? And I'm just going to warn you. This is new, and you're probably going to be a little confused about it, but you're going to get it. It just takes practice. Okay? So, everybody, take a deep breath. Okay? All right. So, in your notebook, you need to try this, writing repeating decimals as fractions. In your notebook. Yep, not by your picture. Not by your picture. Just wait. Pick that. And another thing I would like you to write, and it's not going to make sense now, but it will. If one digit repeats, you're going to multiply by 100. Or 10, I'm sorry. If two digits repeat, you're going to multiply by 100. If three digits repeat, you're going to multiply by any guesses? Yep. Make sure you get that written down in your notebook too. We're only going to talk about 3. We're going to not go too crazy. So if one digit repeats, you're going to multiply by 10. If two digits repeat, you're going to multiply by 100. And if 3, you're going to multiply by 1,000. Yes? So the 8 would just be 10. 8, 1, and you multiply by 100. Just hold your horses. Hold your horses. I will answer your question, Maddie. Probably in an example, though. Okay? No, you don't. I'm going to stump the stumper right now. All right, so what I'm going to do is I'm going to change this decimal to a fraction. Okay? It's an 8 repeating, and you cannot write it 8 repeating with a line over the top. In this case, you have to write 0.888888. You got to write it out. Okay? So first thing I'm going to do, I can take any letter, and I'm going to assign a letter to it, or a variable. Okay? I'm going to say, I'm going to use n. I'm going to say that n equals 0.88888888. You know what I'm talking about? Like when we had homework assignments, they would say A is 6 or B is 5. I'm doing the same thing here, but I'm going to assign the variable this time. Does that make sense? Okay. So I'm going to look at this, and I'm going to say, how many digits is repeating in this? Just 1. My 8's the only thing that's repeating, right? Okay. So first, I want you to write this down in your notebook. Just guess. It's not a big deal. You just have to show that it repeats. So we're going to say n equals 0.88888888, yada, 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 yada. So then you just told me that one digit repeats. So what am I going to multiply by? 10. And if I do something on one side, I have to do it to the other side, right? Okay, so I have to multiply by 10, and if I do it to this side, I got to do it to this side. So let's multiply both sides by 10. So guess what this looks like then? 10n. But guess what this side looks like? 8.8888, so on and so forth. Okay, because remember when I multiply by something with a 0, it moves my decimal over a space? That's all. No. Everybody this far? Okay. You gotta go already? Okay, watch my video. Okay? That's going right now. Huh? Okay, ready, gentlemen? All right, so then what I'm going to do is my goal is to make it so this goes away or disappears or cancels out. So I need everything behind that decimal to cancel out. Okay, just trust me. Okay, and the only way I can do that is to subtract this, right? I have to get rid of it. So let's go back to what we did up here. I'm going to subtract one of those n's. Because what lines up perfectly then? The 8s. Okay, so I took this and I subtracted. This goes away because it reduces, right? 8 minus 8, 0, 0, 0, 0. And I'm left with an 8 on this side because this will come down. And 10 minus one of the n's is, I have 9 n's left. Sure. Go for it. So I'm so close to solving my problem now because I'm looking for a fraction, right? Now, when you solve something that has a variable by it, I want to solve it. I want to just get the variable by itself. Remember, when I solve something, I want the variable by itself. So if I have 9 times n, what can I do to get rid of this 9? Divide by 9, right? Because if I'm multiplying by 9, I need to divide by 9 to get rid of it. Because that reduces, that goes away, and guess what I have left? I have 8 9s left. And if you get your calculator out, if you have your calculator, that's okay. If you take 8 divided by 9, guess what decimal you get? 0.888888. Very good. You don't have to do it. We're going to do another example, though. We're going to do another example. So here's my next one I'm going to do. 0.23232323232323. The first thing I'm going to do, what? I'm going to assign a letter. What letter are we going to use? Y? Sure. We'll do Y equals 0.232323, and so on and so forth. Okay? And if I look at this, how many digits are repeating? 2. So what am I going to multiply by? Okay, so we're going to multiply each side by 100. So this would be 100y, and this would be 23.232323, so on and so forth. Okay, now remember, my goal is to get rid of everything after that decimal. Okay, and to do that, I'm going to subtract what again? I'm going to subtract one of these y's. So I'm going to take this, and I'm going to subtract. I'm going to put one y. That's what you guys like. So then I get 99y is equal to 23, because that doesn't have anything to subtract by, so I'm going to bring it down. Then I'm going to divide by 99. Divide by 99. This cancels, and this is my fraction. And if you don't believe me, put it into your calculator, 23 divided by 99, and I bet you get that. It is. It takes a lot of work. Yep, that's right. Is it right? All right. Should we do another one? Let's do one more. Let's do one more. I bet it is. All right, so I'm going to use X this time. Sure, do it by yourself, yeah. Go ahead and do it by yourself. That's fine. We'll talk it out in a second. You can reduce. Make sure you reduce, too, because this one can be reduced. Hmm? No. I mean, to check it if you want. I don't care. But not for your homework. Guys about done? Okay. I'm going to do it for the girls because they're going to watch this tonight. Shout out to the girls. And the boys who are helping me out doing this video right now. And subscribe to Hunter Gloden, please. All right, so what am I going to multiply by here? How many digits are repeating? Multiply by 1,000. So I'm going to do that in my head, and it's going to look like this. And then this. Okay. Then what am I going to do? I'm going to subtract one of the x's. Okay. And then with 99x equals, this is all going to cancel out, so I have 123 left. Yep, I'm going to divide by 999. I'm not done yet because it can reduce to 41 over 333, and that would be your answer, gentlemen. Here, I always reduce to make all my fractions as small as possible. Yep, so like I knew that 3 could go into everything here. I knew that 3 could go into all these, and I knew 3 could go into this because can 3 go into 12 evenly? And 3 can go into 3 by itself. So that's a quick way to look. Yep. Yep. Yeah, that's how I reduced it. Yeah, if you can just find simple ways. 3 goes into 9, 3 goes into 9, 3 goes into 9. Yes, they might be. You don't need to. I don't know why you would need to use a calculator. No, you can simplify by yourself. That's it. That's it, I believe.